Nature is not purely random, it is structured. Standard computer randomness produces white noise, where every single pixel is an independent roll of the dice. It looks harsh, like television static, because there is no correlation between a point and its neighbor. One pixel might be black and its neighbor white, with no relationship at all. Ken Perlin changed this by introducing spatial structure. Instead of random values at every point, we define randomness only at the intersections of a grid. Let's look at a single unit cell, defined by its four corners from 0 to 1. At each corner, we assign a random unit vector, known as a gradient vector. These arrows act like steering wheels, dictating the direction and slope of the noise as it flows away from that corner. For example, at the origin, we might have a vector pointing precisely to the right, while the top right corner points up. The fundamental difference is that randomness is now sampled at discrete points. To find the value anywhere in between, we must calculate the influence of these four gradients. We have replaced total chaos with a structured field of potential, ready for calculation. To find the noise at point P at 0.5, 0.5, we draw distance vectors from each grid corner to the point. These vectors define the local coordinate system for each corner's influence. We compute the dot product between each corner's random gradient and its distance vector. This measures alignment. If the gradient points toward P, the value is high. If it points away, it is low. A simple average creates sharp seams. To fix this, we apply a fade function, or smooth step. This quintic polynomial ensures smooth transitions by slowing the rate of change at the grid boundaries. Using these faded weights, we perform a weighted average of the four dot products. This bilinear interpolation blends the influences into a single grayscale value for our specific point. Zooming out, thousands of these cells combine. The local gradients act as the bones of the landscape, creating organic hills and clouds. This is the secret to natural procedural generation.